Hello everyone. In this lecture we are going to discuss the most important and most fundamental topic of digital electronics, that is logic gates. Let us understand logic gate with some questions. The first question is, what are logic gates? The second question is, what are the different logic gates which are used in digital electronics? The third question is, how do we recognize them? And the last question is, how do we verify them? Let us understand one by one. So what are logic gates? Logic gates are the fundamental building blocks of any digital system or digital component, or you can say digital device, such as laptops, mobile phones, digital cameras, personal computers, etc. When logic gates are connected with some wires or cables with applied input, and if it produces some meaningful output, then it is called logic circuit, as shown in figure. So it will not be wrong if you will say that logic circuits are the fundamental building block of any digital system. Now coming to our next question, what are the different logic gates? The different logic gates are NOT gate, AND gate, OR gate. These three logic gates are called the basic logic gates. The next two logic gates are NAND gate and NOR gate, which are called universal logic gates. That we will discuss in our future lecture, that why these logic gates are called universal logic gates. The rest two logic gates are XOR gate and XNOR gate, which are derived logic gates. Now how do we recognize the logic gates? The logic gates can be recognized by the symbols or by the DIP IC. DIP IC means dual inline package ICs. Now you can see in the figure that there is a box and there are some logic gates. All logic gates are of similar type. This is a NAND logic gate, which are embedded inside a black box. This black box is called integrated circuit, and which is of DIP type, or you can say dual inline packaging type. Now how do we verify them? Logic gates can be verified with the help of truth table. Now what is a truth table? A truth table is a tabular representation of ones and zeros. These ones and zeros are arranged to produce some output of all the possible combinations of input. So this is all about the introduction part. Now let us understand logic gates one by one, all the logic gates one by one. The first and most basic type of logic gate is NOT gate. A NOT gate has only one input and it has only one output. The input is let A and the output is Y. In the third column you can see the logic equation for NOT gate is given. Y is equal to A complement. It states that if you will supply 0 at its input, the output will be equal to 1, and if you will supply 1 at its input, then output will be equal to 0. So output is always the complemented form of input, where 1 is represented as logic high and 0 is represented logic low. The second logic gate is an AND gate. The minimum number of input for an AND gate is 2, and the maximum number of input can be any number. The inputs are A and B and the output is Y. The logic equation for AND gate is Y is equal to A dot B. With two number of inputs, the possible number of combinations are 4: 0, 0, 0, 1, 1, 0 and 1, 1. Now you can see with the truth table, if any of the input is 0, then output is equal to 0. The output is equal to 1 if and only if both the inputs are 1. That can also be understood with the help of the electrical circuit given here. Now coming to the next logic gate, that is NAND gate. A NAND gate can be designed by connecting a NOT gate at the output of an AND gate. So definitely the logic equation will be y is equal to a dot b complement, and the output will be the complemented form of AND result. The next basic logic gate is an OR gate. The electrical network is shown here. Two switches A and B are connected in parallel, and the logic equation is y is equal to A or B. This plus symbol is called logical OR. Now you can see in the truth table the output is equal to 1 if any of the input is equal to 1, and the output is equal to 0 if all the inputs are 0. The next logic gate is NOR gate. A NOR gate can be designed or constructed by connecting a NOT gate at the output of OR gate. The Boolean function for NOR gate is y is equal to a plus b complement. We can see in truth table that output is just complement of the OR gate. Next logic gate is XOR gate, which is sometimes called as exclusive OR gate. The Boolean equation for exclusive OR gate is y is equal to a complement b plus a dot b complement. Now an exclusive OR gate produces true output when number of true inputs are odd, as you can see in the second and third row of the truth table. Similarly, an exclusive NOR gate can be constructed by connecting a NOT gate at the output of the XOR gate. Exclusive NOR gate produces true output when number of true inputs are even, as shown in first and fourth row of the truth table. The Boolean equation for the exclusive NOR gate is y is equal to a complement dot b complement plus a dot b.